I'm Dennis Spaeth, the owner and publisher of Cutting Tool Engineering. I'm in Gurnee, Illinois today for Champion Now's latest Camp Champ event at the College of Lake County Advanced Technology Center. About 50 middle school students from the Neal Math and Science Academy in North Chicago are here to learn a little bit more about manufacturing. Organized by Champion Now, the event provides these students an opportunity to use a series of tabletop setups that they use to manufacture wood pens and pen cases. That means they each get a chance to work with a CNC lathe, a rotary indexer for sanding and deburring, a CNC mill, an Oasis optical inspection system, a laser engraving system, and finally an assembly area. Let's take a closer look.
Numeric control. So here, numerically controls what's going on. So like with an X, Z, and a Y, it's telling the computer, hey, move up a little bit, move back a little bit, move up a little bit, perform this function. So CNC lathe. So somebody writes this code over here, and you can see the computer just running through that code telling it what to do. And that's the good part about the manufacturing around here now. It's pretty clean manufacturing, right? You just come over here, punch in some numbers, understand how the machine is working, be able to load and unload the product, step aside. Sometimes machines have automatic loading and unloading. So here, check this out. So this was this one code. I got my notes down. That was the bottom. So we're going to do the top. So that's the top. That's 102. That's the code. Let's run 124. Yeah, put that in. Sometimes that happens. I'm going to run. So what I was going to do is switch to this other program. You can see that when you saw the pens, there's two different parts, right? One program's going to the top, one's going to the bottom. I wanted to show you the other one. Now I'm going to run it just so we're going to do the same one, just so we can get caught up here. So all that code is a little different. So hopefully this one stays. Alright, look at this guy. He's set. He's only been a manufacturer here for like what, an hour or so? So every part of the manufacturing, you got to have somebody in there doing quality control like this. So yes, you got automated machines, but we still got to have people like you say, okay, how do I diagnose a problem? Right? How do I fix a problem? Or how do I program, change the program, adjust, right? Because the customer's going to come and say, hey, I want this to look this way.
We're already on the green. Just go ahead and click the mouse. Just click it. Yep. And when that tool comes down, you've got your button. Ready? Okay, go for it. It's all you. See what you did. See it? We have one last cutting operation that's on the inside that's here. So Joe's going to go ahead and change our tool. No, one last tool change. And we're going to go and cut these grooves in. And this is going to be our last tool path. So our tool path is literally the path in which the programmer has told the tool to go. That makes sense? All right? Pretty makes sense. So this is going to be our last tool path, and it's going to be our grooves that a pen would go in. Okay? Okay? So if for some reason this machine breaks down, we have to move to another machine in our plant or something like that, we know that this is our home and that this side for this program goes in a certain orientation, and we can pick up right where we left off. And it'll still be accurate, and we can still make the part. This next machining part of the program is a little over 5 minutes, okay? In a manufacturing facility, you can have a program that could last an hour and a half. It could last 3 to 4 hours, right? So there's different things you can do, right? You could do a second machine for the next one, right? So if you have these 45 seconds little ones, you could do a bunch of those while you have one that does the 5-minute one, right? So you can hold different things. The people in a manufacturing facility that does that, that's a lot of times called your planners or your schedulers, right? They help kind of lay out what would be the most efficient way to do it. So that's another part of it. Are we all set? Okay, who wants to set this one going? Okay, and who wants to do the vacuum?
Anyone? I'll do the vacuum. Yep.
Okay, whenever you're ready, one click on the mouse. There you go.
How does it just this amount of thickness to be able to, for the laser to be able to not
What if I press it? Hold on. Well, we're done. I got a real question for you.
All right.
Jesus. Anyway, so basically when you say you do Jordan with it, how did you get the iron? Or whatever.
Oh, what do you mean?
Like, to inject into that. Wait, hold on. How do you get, what material do you use for the laser to engrave it?
It's CO2. It's powered by CO2.
But like,
And the laser itself is powered enough to hit that anodized aluminum without burning through it.
so,
And I have to be the one to set that power outage up. Like, you have to set the power to make sure that, so say for example, if I'm at 100% power and I cut through it, then I have to kind of dial it back a little bit, like 80%, and if it's still cutting through it too much, 70%, you know what I'm saying? You kind of have to adjust the power to make sure that you're not cutting through your materials.
laser. When the laser is on.
So listen,
Terrible person.
so the laser will know what to do because, like I said, the first thing I always want to do is I want to outline what I'm working on. So I measured those little plates, and based on what I measured on them, I drew these little boxes to match the plates. And then,
In for Neil? In for Neil.
yeah. So after I designed the outlines, I made it so I could fit the logos and the names in between. So it was as simple as me. It was as simple as me placing these boxes in correlation to where I had it on the machine itself, and then I was able to put in an image from up here, and then just drag it and drop it where I wanted,
And then the names.
and then type in the names, and it was good to go. Yeah.
There's a great opportunity, I think you heard me say, there's great opportunities for young ladies in manufacturing. I just talked to them, and Carrie, she works for General Electric. Her parents went to my church 30 years ago, maybe 35 years. And Carrie works for General Electric, making turbine blades for jet engines. And so she's been in manufacturing for probably close to 20 years now. She has a family, she makes good money, so it's something to at least think about when you're being introduced to manufacturing. Okay, so come on over here, and let's have one of you sit down. What we're going to do, come on, don't be afraid, someone's got to sit down. Come on. There you go, be the brave one. So grab the mouse, and what we're going to do is we're going to try to check a diameter. So see here it says DIA, click on that, and then you're going to drag a box over that flat right there. So start, and then drag it down. There you go. And then click on the red and bring it up, drag it up. There you go, that's fine. So what that shows you is it's 0.7195. So that diameter is 719 thousandths and a half diameter. So 3/4 of an inch is 0.750.
I know a lot of people like.
So it's telling you very accurate. Now, when you get to the fourth decimal, that's a 10,000th of an inch. So you have 700 thousandths, 19 thousandths and a half. A human hair is 7 thousandths in diameter, just to give you an idea. So many times in production, you won't make just one at a time. You'll make 20 of a time, and then we'll go down the line and then put them together. So it could take you a day just to do one, but you'd never do that way. You do some assemblies, then do those together, and then put them all together in the final assembly. That's the diameter, so it's going to measure the outside diameter. And then these are lengths. And then you have all your different, you have your tolerance band, your high and your low, right?
And see if it checks if it's like straight on. And out of these, like these pieces of wood are the ones that they're using over there to make it boxes. Your name or
Can you give me, first of all, an idea of what you expected when you were coming out here?
So I didn't know what to expect. I was definitely a little nervous about what students would be exposed to.
And now that you're here and you've had some time to go around, what are some of the things that stand out?
Well, just the opportunities to explore different aspects of the industry. Our students didn't know anything about manufacturing when they came out here at all. Getting some ideas and some actual hands-on experience with that, I think, has opened up maybe some mindsets or some eyes that they weren't thinking about it, but maybe now.
And you had mentioned something before about how engaged the students seem.
So yeah, they do seem very engaged. I even noticed like one young lady was like, I'm sure I don't want to do that, but there are some other things we haven't gotten to yet that I might want to try. So
if you could give me an idea about the opportunity to expose your students to different career paths, how does this rate, and is this one of the few opportunities, or do they have many others?
So not many. Over the last couple of years, because we were also waiting for our school to be finished, we also took classes out at we had our classes at the University Center at the College of Lake County, and so our kids had an opportunity to explore Tech Campus there. We also have a partnership with the Navy. Our community has a Navy base, and so we did a tour or whatever at the Navy base as well last year. So not many, but definitely want to give kids some ideas, because in 2 years they'll have an opportunity to come and get involved in some of this programming at the Tech Campus.
Okay, so we have the welding fabrication technology program here. So the idea is that you weld metal, and then you form metal, right?
Is this okay?
So that's what this area is for. We have about 27,000 square feet over here, about 12,000 square feet over there, which is a lot, you can see. But you know, so this is these original floors from the Lowe's, right? So if you walk this way, manufacturing is changing quite a bit. We're adding a lot more technology into manufacturing. We have this side of the room are more advanced robotic welders. So they have to be programmed. People have to maintain them, program them, fix them. But the idea is that these are welders that basically do the same job over and over again with the same amount of quality. And so that's our story on this side. It might be a little loud, but it shouldn't be too loud. So actually we can stop right here. We'll walk through here very quickly. But you can see we have welding booths in the back. We have 44 welding booths in the back. And on this side, right in the middle, is our machines that bend and twist and cut metal to make everything that we use every day. And you can see we actually have students right now in the welding area. We're going to walk right by there. So come on in.
When I'm showing you that car, that was the bending and the twisting. You said the straight pipes. Choose someone that was doing the specific bends based off the CNC.
So they'll weld together. I would like to weld pipes, flat pieces of metal. So they learn how to do all that on the machines over here. Time you learn more, you get more pay. And you go to different jobs within the manufacturing profession. And that's for all of our programs here. So this is our metallurgy lab. That's where we kind of test out our metals to make sure that they have the correct quality. So we're going to go over here to the next area, which is our industrial technology area. So think about that as like manufacturing, industrial maintenance.
That's all their testing for indications and stuff on their well. The UT, precision UT, and NDE inspection is huge.
Is that pretty good equipment?
Yeah, Magnaflux, yeah. So it uses like a black light to get in. You spray it with like a liquid and a powder, and it'll get into any tiny indication. They use a black light to try and find it.
Wow. And then they can measure from that?
Yeah, and then you can find.
So this is a 12,000 square feet. We have a lab back here that mimics what you see in manufacturing companies with process control. You know, we can't bring an entire factory in here, so what we do is bring the parts of the manufacturing into this building and kind of shrink them down so that students can learn all the different parts that they need to know for their job to work in industrial technology. The way this room is set up is you'll start on that side of the room and work towards this side of the room. This is the more advanced parts of what you're going to learn. This machine specifically is basically a small Amazon and how they move packages around. I know you, Dave, what is your term? You don't like that term though.
What's that?
This is a small Amazon.
No, it is, but the way that you have to look at this is any company can come and move, has a need to move boxes, right? Amazon, Target, this machine was actually designed for Target. But what this is it's everything that you come into contact with from that side of the room to this side of the room, this has every single piece of that. So what this is it's, yeah, everybody knows what a paragraph is, right? So it's like you take letters, and then you make words, and then you make sentences, and now you have a paragraph, right? This is your paragraph of machinery, because every single little piece in here makes up your letters, it makes up your words, it makes up your sentences, right? So this program is 10 different content areas and 23 different classes. So we have pneumatics, which is moving things with air. We have AC/DC basic theory. Okay, we have wiring. We have motor control. We have pump systems, pipe systems, building automation with PLCs, which are the computers that run most of your processes out in the field. Right? We have hydraulics and we have process control. We also do mechanical drives that includes laser shaft alignment. So you actually use lasers to make sure that everything is laser straight, right? So the beauty of this machine here is that it includes all 10 of those content areas. So you have wiring, you have pneumatics, you have hydraulics, you have every single thing falls into this one machine. So when you go through our program, this is the machine you end up with. Now there's a program on here called Fault Pro that'll introduce somewhere around 600 different faults into the system. So you have to know how to run the machine, you have to know how to install the machine, and then you have to learn how to fix every single system. So here's the other part that's fun. Students can write faults for other students, so we make it a competition to see who can trick everybody else, and then you'll get extra credit if you trick your other students. If you can get one by me or my other faculty member Mike, you get lots and lots of extra credit. Haven't had anybody do that yet, but we always look forward to somebody stepping up and king of the mountain, right?
You may be that person right there in this group. So I apologize, we have one more minute left before I have to turn you back. Thank you, Dave.
Not a problem. If you want more information on the program, I'm going to leave some cards. If anybody would like a card, please come and take one. I'm more than happy to do tours on another day, or parents, guardians, stuff like that. I would love to see you, love to have you in class. Come and look into this, okay?
Okay, we gotta get back. All right, thank you, Dave.
We can back for him.
Yes, absolutely.
Hi, Carrie Krasinski. Nice to meet you. Thank you.
Nice to meet you. Are there any questions I can answer, anything like that?
No, I just,
Oh, thank you very much.
I was saying that if this was here 20 years ago, I probably wouldn't have gone into engineering.
Well, we work closely with two different engineering departments. So we have mechanical engineering technology that works with our advanced robotics and mechatronics program.
Yeah.
So MET and
Oh,
R.
definitely. So my husband's an MET. 20 years ago, it wasn't as pronounced.
When we first met with the architects, you know, they said, what are your goals for the building, right? Because that's where you want to start. Whenever you're building a building, what are your goals? You know, we knew we had three goals. Number one, we wanted an advanced technology center. We're a community college. We want to make sure that our jobs are meeting the needs of local industry, that they're high-tech, high-wage, high-skill. That was part of the goal that we had, because we know that's where industry is going. And so that was one of our major goals. We wanted to be an advanced technology center. Number two, we wanted to mimic as close as we could to the manufacturing environment. We wanted students to not be in a square classroom and then automatically then go into industry. So we wanted to create an environment as close as we could to manufacturing for our students, but also for industry. So when they came in here, they would go, oh, high bay spaces, low bay spaces. We wanted it to look like a facility that would be recognizable to industry, right? Because we need their support. And so that was one of the reasons that we, the second goal. The third goal was we wanted to really changed the perception of manufacturing, from dark, dirty, dangerous to high tech, high skill, high wage. And we put a lot of thought into making sure that this was a bright space, that it was clean, that it really represented the best we had in the county related to advanced manufacturing. Because when you drive down the road, you can't look inside of the companies, the factories, right? You can't look inside of AbbVie, Abbott, other companies we have here in Lake County, and we know that you can't be it unless you can see it. So part of our goal as we built this out was to, number one, have this atrium, so we could hold events like this for our high school students, our middle school students. We've had robot fairs in here. We've had counselors in here, superintendents, teachers. So the goal is really to raise the awareness of manufacturing and its impact in Lake County. Lake County is the second largest manufacturing county in the state of Illinois, $48 billion of economic output. So we knew that was part of the story that we had to tell in order to help people realize that manufacturing has jobs, and that we're a part of that ecosystem, that workforce talent pipeline to help Lake County sustain its economic advantage as a place where companies could come find workers, and also to have a place where they can expand and grow in the global economy. So those are our three goals, and you'll see that that's why we have a lot of windows. That's why we have space, and that's why we have this atrium.
Yeah, I got a couple questions for you beyond this. Now, first of all, what is your background yourself?
So my background, I've been in higher ed for 28 years. I have a really strong background in career and technical education. A lot of my background working with career and technical education programs. I have a bachelor's degree in science, a master's degree in education and business administration with an emphasis on business administration, and then a doctorate in educational leadership studies. But my first job in higher ed was working with manufacturing. I was the coordinator of manufacturing programs at a community college. And then before that, I actually worked with manufacturers. I owned my own company, teaching first aid, CPR to manufacturing companies. So I got a chance to understand manufacturers, manufacturing companies, and then that allowed me to say, I'd like to work at a college to work with manufacturing programs. And then kind of throughout my entire career, I've been, one of my passions is career and technical education, and making that connection between, between the workplace and education.
Yeah, and that's what I was wondering. You have such a, you don't have to search for words like I'm doing right now, to talk about everything that this college is doing and what the needs are of the industry. You've got all this in your mind. It's obvious to me that you've had multiple, maybe decades of experience in manufacturing and what the real shortages are with skills and all.
Yeah, so one of the things, just to kind of give you part of that story.
Sure.
So I'm new to Illinois. I've been here 5 years. So when I first got here, I had to go, well, what is Lake County up to? What are we doing? What are the needs?
Yeah.
And it was very obvious that there was a gap between the amount of students we were putting out and demand in the industry. So 5 years ago, Dr. Suddick was also very new, our current president. And so she held listening sessions with manufacturers, and basically workforce 5 years ago, what was a critical need, and that there was this gap. So we've really been working for the last 5 years to create the infrastructure and the systems in order to make sure that there's a pipeline between middle school, high school, the community college, universities as well, and then ultimately to the manufacturers and companies within Lake County. So we've been listening, right? That's how you do it. You listen. Dr. Suddick is definitely has a passion for career and technical education as well. So when I first got here, we did not have full-time welding faculty. We did not have full-time industrial technology faculty. So 5 years later, we have 3 full-time faculty there in the welding fabrication technology, and 2 there. So, and we've made this investment again, 5 years ago, Dr. Sudig recognized we need a pipeline. So now we have what's called a career and college navigator in every single high school in the county. So they're there working with the high school counselors to talk about the College of Lake County opportunities. So that's something new.
What kind of a position is that?
So it's a career and college navigator.
And so is there one for each school, or is it, oh wow.
Well, like for instance, sometimes they'll go on like Monday and Wednesday to one school and Tuesday, Thursday to another school, but they cover all the high schools in the county. So, students that are interested or show an interest, we, can start to talk about pathways, right? We talk about the opportunity that students have based on what they want to do. Yeah, I've been doing this for, like I said, 28 years, and this is right now one of the tightest systems between, to create a pipeline of workers from your community into the need in the community for workers. Yeah, it's pretty exciting.
It's a complete system. It's one of the most complete, most connected systems. When you say tight, that's what you mean?
Yeah.
Okay,
that's
incredible.
It's a complete system, but it also...
there are no gaps.
There are no gaps, and then the other piece is we really try to support the learner throughout the entire process. Like there's also, career and college navigators are before they get to the college, and then we actually have, advisors that work, or coaches that work with students while they're here to keep them in college, right? and keep them in college to the point where they want to be here, not you know what I mean?
Well, keep them until they have tried everything, and if none of it fits their personality or their interest, well, so be it, but at least they tried.
And then they have an option to, you've built this much, then, what are your options? Or do you just need to start over somewhere? Most of the time it's not start over. Most of the time is, how can I build on what you've already done, right? And that's, and then for the college itself, so before this, so right now I'm on special assignment to do those projects I told you about.
Okay.
But I'm actually the Dean of Engineering, Math, and Physical Sciences. And so part of what we've done over that 5 years again is also really revised most of our career and technical education curriculum as well. We actually had a whole process where we would do DACUMs, which is called developing a curriculum. It's a process where you bring people in that are doing the job, and then say, what are these the skills and the tasks that you need to, or what are the skills and tasks you need to do this job? Okay. And then from that you catalog that, right, or you put that in a grid, and then what for the current programs we would then kind of compare that to what we're providing, and go, are there gaps? Did the industry say they needed something and we're providing something else? Because our goal is to provide
maybe you're focusing on too much on one thing, and it's a smaller concern.
Or like to give you an example, for our CAD program, there was a program called Revit that we have a class in Revit, and we were teaching it, and we went through this whole process, and guess what? Revit didn't come up at all. And then we have data, places where we can find data about what employers are putting in their job ads, and Revit never came up in that search either. So we started, do we need Revit in our curriculum? Because our goal is to provide, just-in-time training, not just in case, right? And so part of what we did is, that discipline, we added a sense of discipline to the curriculum so that students could then have a clear pathway with on-ramps and off-ramps, and every single one of those off-ramps leads to a very specific job. So if you get a certificate in this, we know that there are jobs in Lake County that relate to the skills you learned in that certificate. So a lot of what we've done is we've made sure that we are absolutely hitting the mark in Lake County with our program, which is again, it was taken us 3 years. We've gone through 18 different programs to make sure that we're aligned, and it's a lot of work, but it's probably some of the most important work that we do. Yeah. Because we're not here to take people's money, and we're here to find people jobs.